We're going to talk about the present day. I'm going to talk a little bit about the future too. My name is Jonathan Asher. I like to think of myself as the architect behind the current 3D experience for CATIA, 3D experience solutions, because I am an architect myself. I was at Coop Himmelblau for a while in Vienna, and then at Zaner in Kansas City, Missouri, in the United States, where I fabricated a lot of facades from CATIA, from 3D experience. So the presentation from Paul and Felix Construction brought back a lot of memories. I'm going to talk about the current set of CATIA 3D experience roles, processes, applications, and it's going to get a little bit technical. I'm sorry for that, but it's all good stuff. So first, we've recently relaunched our 3D experience for construction, cities, and territories industry. We were CATIA for AEC, Architecture, Engineering, Construction. Now we are CATIA for construction, cities, and territories, where we are bringing all of our solution sets within the context of the city. And we like to say that BIM is a bit product-centric. It's a bit limiting. We focus on building experience modeling, which is modeling within the experience of the city, within the context of the city, which is why we've expanded our solutions into cities and territories rather than just a product-centric building or project environment. So where do we see building experience modeling in the future, as opposed to the building information modeling of the present, going from a fragmented project delivery approach to a continuous and systemic project delivery, going from files and documents to experiences, going from manual reporting to live dashboarding. And I think the presenters that we've seen earlier, Michael, for example, have shown how this experience-based design project delivery will enhance most project team collaborations and new business models that will evolve from this. Technically speaking, the CATIA solution set is delivered through roles. Roles are what users use daily. And we have a set of roles here with the, do I have a laser pointer? Yeah. We've got a new one here, the 3D Generative Innovator. That's xGenerative design, a new application that I'll talk about at the end. The concept building designer, architectural detail designer, building structures designer, 3D MEP designer, and the civil engineering role. We'll go through a bit each one of those. And we think of these roles within processes, and these processes are what people do or departments do on a daily basis. You can see we've got urban planning, concept building design, facade engineering, environmental design, linear infrastructure, bridge and tunnel. These are CATIA-focused processes. And some of the others then are I won't go into the entire Dassault Systemes pitch, but then they're separated by brands and industries, et cetera, et cetera. But largely, these are our main roles here for CATIA for construction. The concept building designer. This role contains a number of applications to do conceptual design. This is Imagine and Shape. We're going to talk about this Thursday morning for the workshop, on how to do conceptual subdivision surface modeling. It's an intuitive interface to do. You can do, as you see here, rectilinear modeling. You can do subdivision modeling. I think Michael's video is actually a lot better than mine. But this is just how to do building massing for what would be two tower projects with eventually a little bridge connection between them. So on Thursday morning, we'll spend a couple of hours doing Imagine and Shape. Michael showed building space planning as well, a new functionality that came out just over this weekend. It's the variable curtain wall. This is a brand new command that's allows you to do conceptual facade design. Paul, you should check this out because there's we've included an extract cells functionality that takes this conceptual design model and outputs all of those surfaces for the setouts with attributes for each panel. Because I spent years and years and years doing facade design with CATIA, writing custom scripts to do the panelization, I worked very closely with the R&D team to develop the functionality for this command so that you can eliminate all of that tedious scripting. What's great about it is you can design one region or multiple regions, you can create these bands, and then you can take that pattern and you can apply it to a different face. So it greatly simplifies and reduces the amount of work that you have to do once you get one design right, and then you've got to work on another face. So this is going to make it all the more easier. And because we've linked this to the detailed-oriented roles with engineering, the digital continuity from the conceptual model to the detailed model remains intact. So one last time we'll show the match, because that's where the magic happens. Here you say select my previously designed one, and there you've replicated your design. Another thing that's really exciting for us is component-based design. This is a technology that we've worked on for a number of years that's really being refined and put to use now to connect the conceptual designers to the detail-oriented engineers. So here, through the use of engineering templates, you can link a volumetric model to a detailed engineering template, and with the click of a button that we call change LOD, you can automatically instantiate those detailed templates that could represent units or prefabricated modules. Here you see we've automatically instantiated units that have been developed by another engineering team, another design team that represent modules or apartment units. Those are preset and come from a catalog, but they can be parametric as well. So here the designer is going to make a parametric volume, get the shape somewhere where they want it, and then associate that volume to an object type that's a parametric washroom. So the washroom is going to include all the information that you would need to fabricate that, and it's because the 3D experience is on the cloud and it shares a database for all project participants. The information that's contained in this washroom is saved to our database, and then it can be accessed anywhere, anytime through the dashboard or through the other project participants who are participating in the project. So now the designer is going to say, well, I need to change the shape of this volume to meet new design requirements. I'll commit that, and the model will automatically update. And you saw before the attributes of that pipe, the length of that pipe is listed here, and now that, because it's all parametric, that's all going to update. And the designer can continue going on manipulating their volumes and working within the adapting their design, and those components are going to keep updating. Where that can go, well, if you have these, here's an example of a parametric bathroom pod, and these can be predefined modules or preconceived modules that are then updating automatically and as the designer is tweaking, manipulating their design, these parametric pods, these bathroom pods can update. And it can be taken further all the way up to a detailed assembly for an apartment unit. This is a small studio that contains that bathroom pod. So we're starting to nest these intelligent components, these parametric components into the model. And we can include fabrication constraints and fabrication requirements into the model as well. So we see as we start to change the layout of one of these this unit, say we want to make it wider, so we'll go up to 17 feet, we can embed manufacturing rules saying, now we've exceeded the North American trailer sizes for this unit. It's not fabricatable this way, or it's not deliverable in this way anymore. But we can choose to ignore that if we want. All of that same information can be opened up in Delmia, a sister application on the 3D Experience platform, and there we can do our manufacturing bill of materials. We can just define our process planning. We can say we're going to associate not only cost but time to each one of these elements. We can visualize that in the Gantt chart, and then we can take all of that information and run it through process planning and simulation to go up and do our 4D simulation for installation. So we've seen now our aim is to industrialize the construction process and say that we can go from a conceptual design model using these components that have been fully vetted out for manufacturing into an industrialized setting for manufacturing, delivery, construction. At any time you can pause this simulation, you can go in and you can do your measurements, continue on. And even though the 3D Experience platform in CATIA, we're the 3D Experience company, we don't like to do drawings. We know that it's a reality in most of our lives. So we have built in a drafting workbench, and we continue to improve it, even though we reluctantly continue to improve our drafting capabilities, even though it's not something that we really like to focus on, because I gotta tell you, as a part of R&D, my life is, I don't wake up in the morning to say I'm gonna make drawings better today. I'd much rather work on some of the more interesting projects that you'll see coming up after this. And again, I'm not gonna, this is all 2D information for assembly. You can do your architectural layout drawings. But the real heart of all of this is that it comes from a 3D model, and the 3D model is almost infinitely scalable. Okay, you can build these models to massive models to a very high level of detail. A Revit model at LOD 400, I'm sorry, that blows my mind, but at LOD 450 in CATIA really doesn't seem to do it much problem. Here's the architectural detail designer role. This is where you're going to be building solid models for manufacturing. This is an example of a facade. A larger assembly, a 5-panel assembly, that gets referenced into a conceptual model that was done with xGenerative design. And then for this example, we're going to do a simple assembly pattern, which is going to automatically instantiate that same 5-panel unit around the building to do simulations for installations, et cetera. This isn't really managing any of those eccentric, non-typical conditions, but it's showing the power of instantiating that many panels into one model. The 3D MEP designer is for mechanical, electrical, and plumbing. The great thing about CATIA is that you can embed specifications for parts as well into your model. This isn't just geometry, this is information. Information within the context of a larger building. This is actually the mechanical systems for our metal building. We modeled our 5th building on our campus in Vélizy. And this is an example showing then the design review between the as-built and the as-designed condition. Building structures designer. The building structures designer is for conceptual and detailed design of concrete structures and steel or steel. Here you see, this is again the metal building from our campus. And we've recently released a new rebar application to do concrete structures. And here you see the interface of how you can adapt, you can use preset bar configurations and bar types that come with the software. You can manipulate the patterns, and then you can design within the context of the building to identify clashes, eliminate clashes, etc. I'll skip through this because I'd prefer to talk about xGenerative design and the new 3D generative innovator role. This is a role that was released back in November. We kept it hush-hush for a couple of years because we've been working on it for a long time. But I think I was here a year ago where we talked about this to a smaller group for Zaha Hadid people. What is it? It's a new web application. It's a web application to do generative modeling. You can do either the graphical scripting that everybody knows and loves and is very fond of, or you can do the same type of modeling through a dialog box. This is what we're going to spend most of the day on tomorrow in the workshop. What is xGenerative design? Well, it's one application that lives among the ecosystem of other applications that are connected through the same common data environment of the 3D Experience platform. But it's a revolutionary product because it bridges the gap between an advanced user and a beginner user. So at any point, if you want to get into graphical or generative modeling, you can use the dialog boxes. You can model traditionally as you would any other 3D modeler. Or if you're an advanced user, if you're starting to explore the application and get into those more advanced stages, you can open the graphical scripting window and you can start adding additional logic and making more comprehensive, more sophisticated scripts. It's one of my colleagues likes to say it's coding without the code, because you can do this generative modeling without actually getting in and writing any scripting or getting into the graphical modeling, graphical scripting if you don't want to. This video is interesting because it shows one of the main functionalities here is that if you want to model in 3D and you have the graph open on the side, you see we build that graph for you. So even if the graphical scripting window isn't open, you're modeling on the web in a dashboard interactively with geometry. It's creating this graphical script for you in the background. If you want to open that window, you can do that and you can start to model. We also have what we call the controller panel. So you can launch, if you're a senior designer, if you didn't build the model but you want to share your model with somebody, you can send somebody to the dashboard. They can open up the controller panel and they can start to model or play with your parameters to start to explore the design space within which the designer has created or designed their model. And so now what you're doing is you're not designing for a specific product or a specific design case. You're designing for a design space, to explore a design space, which is going to open up the world of possibilities into a more open, more creative process. And what can you do with that? Well, we can start to link our new web applications together. So this is an example of, if we're going to do urban planning, urban design. This was a video from Nicolas Senemo, who's right here in the audience. He's going to be leading the session tomorrow on xGenerative design. You can model this little neighborhood condition where you have the fringe, you have the interior core, you have all of your parameters here organized into regions. This is a region right here that's been collapsed, but that's where all the computation is happening for this zone. And when he modifies the parameter over there, it's going to update the geometry. It's outputting a number of values here so that you're modeling with data as well. You're capturing that data, those KPIs that can be measured against each other. And then that same model is represented in 3D Experience City, which is our city environment for exploring the regions, territories for larger large administrations or public entities, or educational institutions, people with larger campuses that want to manage more data than, say, an individual building. xGenerative design, because it's a part of CATIA and it's a part of the 3D Experience platform, it shares the same database. So these are 3 examples showing the digital continuity between a conceptual generative model and a traditional CATIA workflow, where you can, in this video, we're showing how to do a feature wall. You start in CATIA, the rich client. You go to xGenerative design, you start to model a feature wall, you save it in the database, and then you can refresh your CATIA model, and it reflects that change. This is an example of starting in xDesign, which is another web application that was released a year or so ago, with xGenerative design, and then we do a sheet metal assembly pattern. And then this is an example of taking a template-based approach where you create a triangulation pattern and then engineering template for a facade and instantiate that using traditional knowledgeware from CATIA. These videos are all online on our YouTube webpage. I show this example because it's local, right? The Floral Street Bridge. It's also one of the first digital project, which was CATIA V5 tutorials that I did when I was learning CATIA. It's also one of the first tutorials that I taught when I was a professor. And this example, to model this in CATIA, our digital project, was a 3 or 4 or 5 hour task. And with xGenerative design, it is maybe a 3, 4, or 5 minute task. So the difference in process and the difference in performance is phenomenal. Again, I said all of those videos are on our YouTube page, so if you want to check it out, shameless plug. And xGenerative design then, so what is it? It's this graphical scripting parametric modeler that's a part of CATIA that is really going to extend and become a backbone of our future solutions. Which leads us into where we're going in the future. I'm a part of R&D, so I get to deal with our developers on a daily basis, and I share the vision of the industrial leaders to say, where are we going to go and how are we going to get there? So one of the big things we've talked about is this fourth industrial revolution with these cyber physical systems and a new reality of augmented and virtual reality. One thing that we're working on as an industry disruptor is a one seamless platform for submissions and approvals so that we can eliminate paper and go fully digital. We address what we call the ABCs of the industry, the administrations, the businesses, and the citizens. So how can all of those people interact on the same platform to extend a project from each one of those entities as a service? Another thing is the new reality, so of augmented reality and virtual reality. These are two R&D projects where we're on the left-hand side, we're modeling within the context of a point cloud scan, so it's not really augmented reality, it's a mixture of virtual and augmented reality. And then on the right, another R&D project of modeling with virtual reality. This is the building scale, but the first little hint at the future, our first offering in this will probably be more at the urban scale than the building scale. Artificial intelligence and machine learning. This is also, it's big on everybody's mind within the software industry. It's also big on our mind in the software industry. And we're combining that with cloud computing. So how can we take cloud computing with our xGenerative design solution, mix that with artificial intelligence and machine learning to build these new breeds of software that's going to provide design guidance and design assistance and automate those processes by extending the capacity of the designer, not just not overtaking them, but extending their capacities. And finally, every year we hold a hackathon at the Milan Design Week. This year we're holding our hackathon on what I'm coining data environments. Data environments, which gets on the topic that Filippo started with at the beginning of the day. Within the last 2 years, we've generated more than 90% of the world's data. It's really hard to believe, but that's a shocking statistic. That's true. Between the amount of photos and Facebook and Instagram and all of that data, our data is data that is exponentially growing. So I love the video that Filippo showed this morning on that future data-centric city. And so the hackathon that we're having this year at Milan is taking our web applications and designing and creating this vision of what is this data environment that we're creating and the future of our society and our culture. So that's another, it's the very beginning of our thought process towards where we're going in the future with software for design and engineering and construction. And that's it. So it's the end of the day. We'll end it there.
Do you have any questions for Jonathan? Because you're talking here to a centre of the R&D team, so it's a good opportunity to pick his brain if you wish.
Yes.
So you mentioned web apps many times. So does the data live on your servers, or does it live on company servers, or can it vary depending on the situation or scenario?
It can vary depending on scenario and client. We have 3 offers today. We have on-premise, on-cloud, and private cloud. When I talk about the web apps, most of those are on public cloud. Public cloud meaning and they're not even generally our cloud. We're using Amazon Web Services or another public cloud provider. Well, they're primarily our #1 source. So we're housing all of that information on a third-party server, and that's the industry standard at this point. And to be honest, everybody's doing it. Lyft is doing it. Uber is doing it. Facebook, not Facebook, but everybody's working through Amazon Web Services or Google. And for the most part, most of our government clients are even okay with that. Except for in China. So we have an agreement with Huawei in China to do the public cloud offering in China. In that case, yes, we're even using, we're for xGenerative design, all of the computation happens on the remote server, the web server, and all that you're getting is, we're streaming not streaming, we're sending the graphics back to you. So we are using your web browser's RAM to display graphic information and to interact then with the geometry. Yes, because of our arrangement with Amazon Web Services or whoever we're using, we have almost infinite scalability, and we have these virtual machines. So we rent virtual machines, we install our software there, we execute our software, we run our software from these machines, and they have I won't say infinite scalability in computing power because that doesn't exist, but we have. We're able to scale, yes. Yes.
With xGenerative, is it based on EKL language, or can you go to EKL and go back and forth between those and not work?
So the question is, with xGenerative design, does it use EKL, which is our engineering knowledge language? A little information, EKL, engineering knowledge language, is our scripting language within CATIA. We invented it, although it does have roots in Java or Python, or it shares a lot of commonalities with those other scripting languages. It is not based on EKL, but it does include now components in EKL. We just had a new update over the weekend, a week and a half ago, where we released an update, FD01, a functional delivery 01, for our 19x release, which was released in November. And in this new release, or in this latest release, we've included the script editor, so you can start to code with EKL inside of xGenerative design. Yes.
Okay, at the end you should implement them in your state, but in the process, how it would be nice to have like the possibility to link redmark drawings to an object in the model so that we can easily then update before delivering or after the model.
I'll simplify your question. I should have given you the microphone so everybody could have heard. The simplified question is, can you, apart from COBie attributes, how do you attribute information to the objects within your model, such as drawings or PDF, other information like that? We don't have all of the COBie attributes embedded in our data model. We do have all of the IFC attributes, so you can assign any IFC attributes that you like, and you can assign, we have a number of generic attributes that you can assign to these objects as well. So if you have custom attributes that you want to assign to all objects on your database, you can do that. And then we have multiple, because all of the data, all of the geometry, all of those objects live as individual objects on the database that can be accessed through multiple different clients, through multiple different portals. That information is accessible and modifiable given permissions and given rights at any time for different people. So me as a user, if I'm in CATIA, I can assign information to objects as an author. If I'm a project manager, I can go to the dashboard online. We have a number of different applications, web applications, where you can access the same information, the exact same information, whether 3D or as a list of objects, and modify or change or update that information or add information without having to go through CATIA. And on top of that, you can tag geometry as well. So all of this is on the database. We don't have a file browser. You have to search. You have to use the search command to find any of your objects, to find any of your geometry. And to assist with that search, you can tag. You can use the common 6W, we call them 6W tags, the what, when, who, where, why, how. Or you can add additional custom tags to layer more information on top of that. And so, and because you can do that through the web interface, through the rich client, which you download, there are, depending on your role within the company, your role within the project, you have access to different types of information through different interfaces. Because the 3D experience platform is vast and enormous. And so we try to keep it as focused to the individual as possible.